Okay, so this last lecture on the independent samples t-test is going to just show you how to calculate the effect size. Okay, so we've already failed to reject the null hypothesis, and reported our results, and so now we need to calculate an effect size to see if maybe there was something going on there, but we just weren't able to detect it. All right, so the Cohen's d formula is the absolute value of the difference between the means for the two groups divided by the square root of sum of squares 1 plus sum of squares 2 divided by n1 plus n2 minus 2. So essentially, it is the the difference between means divided by the standard deviation. But if you were paying attention, you should notice that that part of the formula, that standard deviation formula, is actually quite familiar, right? Because this is representing the average standard deviation for the two groups, the two independent groups. But if you look here, when we calculated the standard error of the mean, right, and I'm going to just shove this over here for a second, you're going to see that we have already used that formula in calculating it, right? So we have the standard deviation here times 1 minus n1 divided by n1 plus 1 divided by n2. So we already have this value calculated, all right? We also have the mean difference value calculated when we did our t-obtain, okay, which was 0.54. So really there's very few steps. The only thing that we're going to have to do is take the square root. So this is actually what this value here is, the variance, right? So all we're going to have to do is take the square root of that value in order for us to get our standard deviation. So that's really kind of nice, is that we don't have a lot of additional calculations that we have to do to get Cohen's d. All right, so we know that we have the absolute value of 3.32 minus 2.78. Oops, sorry, absolute value, divided by the square root of, and if we work through this, we see that the actual value that we need is 0.2525. See, very few steps involved in doing this. So we know that the difference between those two values is 0.54 divided by the square root of 0.2525. Right, and that's going to give us 0.54 divided by 0.5. Oh, I don't think that makes sense, so bear with me for 1 second. I must have done, when I wrote this down, I must have done it backwards, so bear with me for 1 second as I pull up my calculator here real quick. See, I even make mistakes. Actually, you knew that. All right, so 0.54 divided by 0.5 gives us a Cohen's d of 1.08. Okay, so essentially what it's telling us is that even though the difference between those two group means is not statistically significantly different, they actually differ by more than a standard deviation. All right, and so we consider this, using Cohen's nomenclature, a large effect. Now, we talked a lot about type 1 and type 2 errors when we talked about hypothesis testing, and if you recall, type 1 error is a false positive where you reject the null inappropriately, and a type 2 error is when you accept the null inappropriately. Well, the fact that we have a large effect and yet we still did not find statistical significance suggests the possibility that we have made a type 2 error. Now, do we know that for sure? No. But our sample size here was very small. I believe it was an n equal to 10. Yeah. Which left us with 8 degrees of freedom. And if you recall, the t-distribution depends largely on the size of the sample. It's flatter in the middle, so there's more more values in the tail, making it harder to reject the null hypothesis. So in this case, because we have a small sample size, it is going to be more difficult for us to detect an effect that exists, and therefore we are at increased risk of making a type 2 error. All right, that's all I wanted to say on independent samples t-tests. Thank you.